Good morning friends, and as many of you requested me to do video on physical chemistry, so I am doing this video. In this video I will be talking about Debye-Huckel limiting law, its physical significance, its application. I will not derive the equation because it is not important for your competitive exam. Also, I cannot derive it. I am not very good at derivation, right? But I can tell you the physical significance and how can you apply it in your numerical problems. Okay. I want to start the video by saying that when you measure your conductance versus concentration, that is how your how the conductance of a particular electrolyte varies with its content with its concentration, you get these two curves, right? So this is conductance, and so y-axis is conductance and x-axis is square root of the concentration of your electrolyte. Now you can see that for weak electrolyte, as you decrease the concentration, that is you uh, dilute the solution, the conductance increases, and this increase is not linear but it is exponential. That is, it is very much sensitive to the increase in your decrease in your concentration there, and you cannot predict this by a simple equation. But for weak electrolyte, we explain this increase in conductance by saying that for a weak electrolyte like acetic acid, they are very slightly dissociated in a large concentration. That is, when the concentration of acetic acid or like the other weak electrolyte is very high, then their dissociation is very low, and that's why we know the conductance is due to the dissociated ions. So if the ions present in your solution is low, then obviously the conductance will be low. But when you dilute the solution of a weak electrolyte, the dissociation limit of the electrolyte increases, and that's why it increases the conductance of your solution. But you can see for KCl, which is a strong electrolyte, and we know strong electrolytes are 100% dissociated even at very high concentration. So then why by decreasing the concentration, its conductance will increase? So this to explain this we cannot explain this by saying that as we dilute the solution of KCl, it become more dissociated, and that's why its conductance increases, because it is almost 100% dissociated at any concentration. So to explain this phenomenon, that why the conductance of KCl solution or other strong electrolyte solution also increases with increasing dilution, we have to use the for relationship known as Debye-Huckel limiting law. Okay, so what is the Debye-Huckel limiting law? So the equation is given by log gamma plus minus is equal to minus a into z plus z minus into I to the power half. Now you have to be familiar with these few terms. That is, what is gamma plus minus? This gamma plus minus is called mean ionic activity coefficient. Okay, and this I is called ionic strength. And you can see this Z plus and Z minus are the charge on the positive ion and the negative ion, and this A is a constant. Its value is normally 0.51. At normal temperature, its value is 0.51. So this equation is basically the relationship between the mean ionic activity coefficient and the ionic strength of a solution. Now, what is ionic strength? So ionic strength means in a given electrolyte solution, the power of the solution, that is the electrical field produced by the ions in the solution, is called ionic strength. Now it is obtained by, so I, how we can calculate I? So I is equal to half into summation over mi zi square, where mi means molar concentration of ions and zi is the charge. So let's say we have sodium chloride solution, and let's say its molality is m, and and the charge we can see it is plus and minus. So when you calculate the ionic strength, it will be half into, so for so the overall molality of the solution is m, then it will be same for both Na plus and Cl minus. So it will be m into 1 square. 1 means the charge, and plus m into minus 1 square. So overall you get 2m by 2 equal to m. So this is for NaCl. Now let's say we have MgCl2. Let's say we have MgCl2 and molality of the solution is, let's say, X. So then the ionic activity and the ionic strength we can calculate as half into, so for Mg we have X, the molality X into its charge is 2 plus, Mg 2 plus here, so it is 2 square. But you can see Cl minus, there are 2 Cl minus, so we have 2 into, for every Cl minus the molality is X and the charge is 1, so 1 square. So we will have half into 2 4x plus 2x, that means 6x by 2 equal to 3x. So this is how you have to calculate the ionic strength of a particular solution, and these questions are frequently given in CSIR exam or GATE exam. So this is very easy and you can get easily 2 marks from this. So this is how you have to calculate the I, that is ionic strength. And what about the mean ionic activity coefficient? So in case of a pure solution, you can use your concentration as the measure of your all electrical properties, all physical properties, all chemical properties. But when you are dealing with a dilute solution where there are more than one component, then you have to use the activity instead of your concentration, and this activity is given by a plus minus. We can consider the mean activity of any cat. So let's say we have a dilute solution of NaCl. So then for activity of each Na plus and Cl minus, that is how much they are active, how much they are participating in the physical properties or chemical properties, this is called activity. So activity of any of the ion Na plus or Cl minus is given by A plus minus is equal to gamma plus minus into C plus minus, where C plus minus is the concentration. So let's say the concentration of sodium chloride, that is, let's say you are preparing a solution of X concentration, the concentration of X gram per cc, it is the concentration of your NaCl solution. But you cannot decide the physical or chemical properties of the solution by considering this X. You have to determine the activity, mean ionic activity, and that is A. So how can you get A? So you have to multiply a term, that is gamma plus minus, to this concentration, then it will give you the mean ionic activity. And so A plus minus is equal to gamma plus minus into X in this case. So this gamma is called mean ionic activity coefficient. And the Debye-Huckel limiting law give you the measurement of this mean ionic activity coefficient, and you can see, so this is the Debye-Huckel limiting law, you can see, which says that the logarithm of the mean ionic activity coefficient of a solution is linearly proportional to the square root of the ionic strength of that solution, because these terms are constant. So which questions are given from this topic? So we can plot this log gamma plus minus with I. Now you can see this term is constant, this a z plus z minus is a constant term. Actually it is not truly constant. This a is, although this a is constant, but your z plus z minus term, varies with different ions. That is, if you have NaCl, then z plus will be 1, z minus will be 1, and in this case z plus z minus is given as mod. So it is given as mod z plus z minus. That means for NaCl, although the charge is plus 1 and minus 1, when you took the modulus of minus 1 and plus 1, you will always get 1. So you can see for NaCl it is 1, but for MgCl2 it is 2 into 1, that means 2. That means it varies with the charge on the ions. So when you plot this log gamma plus minus versus I, that is, let's say this is your plot. So y-axis you plot log gamma plus minus, and x-axis you plot I to the power half, that is square root of the ionic strength. Then you will be getting a curve like this, because you can see the log gamma plus minus equal to minus of z plus z minus a into root over I. Due to the presence of this negative charge, the slope will be negative, so this slope will be negative. Okay, now the slope of this curve varies with the charge on the ions. That is, it actually, the slope is determined by this z plus z minus, and as I told previously that this z plus z minus will be different for different salts. Like for NaCl, it will be lower than MgCl2. So as z plus z minus will increase, the slope will be more steeper. So if you have given these two curves, so you can see this is steep, this is more steeper than this one, and you are given these two salts, NaCl and MgCl2. So you have to um, correlate which curve is for which salt. So you can say that for MgCl2, as the slope will be steeper, so it will be for MgCl2 and it will be for NaCl. So these simple questions they give in your exam. Okay, you have to tell for which salt the slope is which, and that you can tell by looking at the charge z plus z minus on the ions. And also they can give questions from this particular equation also. That is, they can give you the a I or and z plus z minus, and you have to determine the gamma plus minus. Or they may not give you the I, they just can give you the concentration of the solution, and from that concentration you have to first determine the I, then you have to put the value of I here, and that's why you can calculate the gamma plus minus. So these are the main important things of Debye-Huckel limiting law, and I think I covered all the important aspect of this law. So this video will be helpful for you, and if you like the video, then also let me know in the comment section and give thumbs up. And if you want more videos on physical chemistry, also let me know. So thank you for watching.